The summer that nearly broke IND USDR way the air inside the factory felt alive, thick, wet, and suffocating. It clung to skin like a second layer. Ink refused to dry. Paper curled and warped as if it had a will of its own. Workers wiped sweat from their brows only to feel it return seconds later. Machines groaned. Deadlines slipped. Tempers rose. It was the summer of 1902 in Brooklyn, and something as invisible as humidity was threatening to bring an entire industry to its knees. Inside the Sackett-Wilhelms Lithographing and Publishing Company, a problem had emerged that no one could solve. Printing, an industry that depended on precision, was falling apart. Colors no longer aligned. Paper expanded and shrank unpredictably. Every job became a gamble. Desperation led them to a young engineer, quiet, observant, and relatively unknown. His name was Willis Carrier. He wasn't trying to change the world, he just wanted to fix the air. What he ended up creating would redefine how humanity lives, works, builds cities, and even survives. Before humans controlled the air, long before machines could cool rooms, human life revolved around climate. Civilizations rose where the environment was tolerable and collapsed where it was not. In regions like Egypt, people built homes with thick mud walls to keep interiors cool. In India, courtyards, shaded verandas, and water features created microclimates that offered relief from oppressive heat. Across the Middle East, towering wind catchers, ingenious architectural structures captured breezes and funneled them into homes, creating primitive cooling systems long before electricity existed. Yet, these solutions had limits. They depended on nature. They worked only in certain climates. They could not control humidity. And they certainly could not support the demands of industrial society. As the Industrial Revolution spread across cities like London and New York, a new problem emerged. Factories became heat traps. Steam engines, machinery, and crowded labor conditions created unbearable environments. Productivity dropped sharply during summer months. Workers fell ill. Equipment malfunctioned. In many ways, heat was an invisible ceiling on progress. And no one knew how to break it. The problem no one experienced. Crisis at Sackett-Wilhelms wasn't about comfort, it was about survival. Printing required precision. Even a slight change in paper size could ruin an entire batch. But humidity made paper absorb moisture from the air, causing it to expand. When it dried, it shrank again. Colors that were supposed to align perfectly began drifting apart. Imagine printing a magazine where each color layer misses its mark. The result: blurred images, wasted materials, financial losses. The company needed control over the environment itself. That meant controlling moisture. That meant controlling air. And that meant solving a problem no one had ever solved before. The mind that saw the iron via side. Willis Carrier was not a showman. He wasn't famous. He didn't seek attention, but he had something rare: the ability to understand systems others couldn't see. Working at the Buffalo Forge Company, Carrier specialized in heating systems. Cooling wasn't even his primary field. Yet, when the problem arrived, he approached it differently. Instead of asking, "How do we cool the air?" he asked, "How do we control what's in the air?" This shift in thinking would change everything. The night that changed history: one evening in a train station in Pittsburgh, Carrier stood surrounded by fog. The air was thick with moisture. Visibility dropped. Everything felt different. And in that moment, something clicked. He realized that by controlling temperature, he could control humidity. Cool air holds less moisture than warm air. If he could cool the air enough, he could remove moisture from it. That was the breakthrough. It wasn't just about cooling. It was about controlling the relationship between temperature and humidity. This insight led to the birth of modern air conditioning. The first machine that controlled CLI-MATE Carrier system, installed in 1902, was revolutionary. It used coils filled with chilled water fans to circulate air-controlled airflow systems as warm air passed over cold coils. Moisture condensed and was removed. The result? Stable humidity, consistent temperature, perfect printing conditions. For the first time in history, Humans had engineered a system that could control indoor climate with precision. But something unexpected happened. Workers felt better. They worked faster. Errors decreased. Productivity increased. The machine designed to fix paper had improved human performance. And that changed everything. The science of cooling at its core, air conditioning works on a simple principle. Heat moves from warmer areas to cooler ones. Modern systems rely on refrigerants to absorb and release heat, compressors to circulate these refrigerants, evaporator coils to absorb indoor heat, condensers to release heat outside. The cycle repeats continuously, removing heat and humidity from indoor spaces. It's a controlled loop of energy transfer. Invisible. Constant. Essential. From industry to everyday life. Initially, air conditioning was used only in industries, textile factories, food processing plants, pharmaceutical labs. In 1911, Carrier presented his findings to the American Society of Mechanical Engineers, laying the scientific foundation for the industry. But the real turning point came in 1925. Movie theaters began installing air conditioning. Suddenly, people flocked to cinemas not just for films, but for comfort. This changed entertainment forever. Summer became blockbuster season. Retail stores followed. Then offices. Then homes. Cooling was no longer a luxury. It was becoming a necessity. Life before air conditioning in modern CITA is before widespread air conditioning. Offices slowed down in summer. Schools shortened schedules. Cities became nearly unlivable during heat waves in the United States. Population growth was concentrated in cooler northern regions. Hot regions remained underdeveloped. Climate dictated opportunity. The rise of the sun. BLT air conditioning changed geography. Cities like Phoenix, Houston, Miami experienced explosive growth. These regions became economic powerhouses. Without air conditioning, their growth would have been impossible. How air conditioners? BLT modern air conditioners require copper tubing, aluminum fins, compressors, refrigerants, electronic controls. Companies like Carrier Global and Daikin Industries lead innovation today. Manufacturing involves precision engineering, testing, and assembly of complex systems designed to operate efficiently for years. Air conditioning and the modern WOLD day. Air conditioning is everywhere. Homes, offices, hospitals, airports, data centers. Without it, computers would overheat, medicines would spoil, buildings would become uninhabitable. It is one of the most important technologies of the modern age. The double-edged WOD. But air conditioning comes at a cost. Negative impacts include high energy consumption, increased carbon emissions, contribution to climate change. Ironically, the very technology that protects us from heat also contributes to global warming. The future of The future of air conditioning includes smart systems powered by AI, solar-powered units, eco-friendly refrigerants, passive cooling architecture. The goal is sustainability. Cooling without harming the planet. The power to control. CLIM80 air conditioning didn't just make life comfortable. It changed where we live. How we work. How we build. How we survive. From a printing problem in Brooklyn to a global necessity, the story of air conditioning is a story of human ingenuity. But as the planet warms, the question becomes more urgent. Can we continue to control the air without losing control of the earth itself? The answer will define the next chapter of human civilization.